Good morning, everyone, and welcome to the second day of Apidays Paris. My name is Jannika. I'll be hosting this stage, so this is stage number 3. And in the first session, we'll be talking about API integration and security. As always, feel free to take part in the conversation and put your questions in the comments, because after each speaker, we have time for a short Q&A session. So we'd love to hear from your thoughts from the audience. Without further ado, I'd like to welcome our first speaker. So we have Sal from WIB. Good morning, Sal.
Hi, Janica. How's it going? Hi, guys.
How are you? Good to have you here.
Thank you.
Without further ado, I'm going to let you introduce yourself, give a brief outline of what exactly it is that you'll be talking about today, and then I'll meet you here on the stage in about 20 minutes, and then we have time for some audience questions afterwards.
Fantastic.
Stage is yours.
Hi, everyone. Thanks for joining. My name's Sal Rafaeli. I'm a group manager at a company called WIB, wib.com, and I'm going to be talking to you today about our attack simulator and about the concept of attack simulations in general, and the value that simulating attacks using an attack simulator can have for your API. The idea, in a nutshell, is to find your vulnerabilities in your API in the field before anyone else does. So, a couple words about WIB. We are a full API lifecycle platform defending against API security threats. We offer a suite of products throughout the lifecycle of APIs. We're led by cybersecurity leaders in Israel. We develop AI to defend the API throughout the lifecycle. As I'm sure you know, API security is a very big issue these days, and every organization that has any sort of web application has an API and is vulnerable to external attacks. That's what we're all here to talk about today. At WIB, we have 4 products throughout the API lifecycle that are meant to defend the API of message inspection, compliance defender, internal code analysis, and an external tool called an attack simulator. This is the product we're going to focus on today. An attack simulator is a product meant for both development and production environments. It enables a security team to simulate an API attack or a whole suite of API attacks with a single click. This allows the security and development team to detect and remediate potential vulnerabilities in the APIs, both before the code is live and after in production environments. Why should you simulate attacks on your APIs? What are the benefits for doing so? Obviously, you're looking to find the same vulnerabilities your attackers might find and probably will find, and you want to find them before they do. You want to automate pen tests against all known attack vectors against your APIs. And you really want, if you're security-minded, you really want to be throwing the kitchen sink of every possible API attack at your API, because your attackers certainly will. So again, our attack simulator is a product which allows a security team to simulate what an attacker would do. We're going to simulate an API attack. We're going to simulate, in fact, every possible API attack we can think of with a single click. And this will help us find automatically all the vulnerabilities in our API, all the security problems that we have in our API. We can find them by running a simulation of an attack and uncovering the results and propagating all the necessary remediations for the security team. We can do this again, either on a staging or test environment or in production. There are benefits for both. Some organizations and teams like to focus on testing while a product is still in development. Other organizations realize that, or maybe this is just my personal bias, that you have to test in production because your attackers are attacking the production environment, which often differs significantly and has security problems that are you won't find them in the testing environment. So you really need to simulate attacks both in development to find vulnerabilities before they're live, and in production to find the vulnerabilities that are actually found in the field. This is the end result of an attack simulation. A successful attack simulation results in a list of vulnerabilities, each vulnerability with as much information as possible about how to replicate it, and of course for the development team, how to fix it. I'm going to dive deep now into the list of remediations, into how we create them and how an attack simulation runs. The value of an attack simulation can be found in this list. It's a list of vulnerabilities, list of successful attacks. Successful not necessarily in the sense that they actually exploit data, but in the sense that they uncover a part of the API where security has not been applied correctly. So we're using the OWASP top 10 vulnerability list as a guide for what sort of vulnerabilities we're looking for. We craft the attacks using our knowledge and AI. And in the next few slides, we'll dive a little bit deeper into how exactly we create these attacks and just from a technical perspective, how this is achieved and how this is run. And the end result is something like this. It's a list of the vulnerabilities and security issues that your API actually has in the environment that you tested. So again, in this list, we can see the API that we were testing here. We have a list of vulnerabilities where parameters sent in different type uncover mismatch vulnerabilities. We have SQL injection vulnerability uncovered. We have Ebola problem, broken object level authorization, admin access problems, method change. Each one of these is an example of an API security issue that can be uncovered using a simulated attack. Of course, the same problem would be found by an actual attacker if they got to your API before you ran a simulation of an attack and found the vulnerability yourself. This is why an API attack simulation is so valuable and really a must-have to verify that your API has been tested against attacks that will come from the attackers, and we want to find them ourselves before that. So again, this is a list of remediations of problems, of vulnerabilities. Now we'll dive a little bit deeper into how we execute such a simulation. We start with Postman. We use Postman as a standard because it's such a ubiquitous tool for developers everywhere in terms of how to model an API and how to model an API session. It's important to remember that APIs often cluster endpoints together in the sense that the business logic relies on a session, a sequence of calls. It's not just a single HTTP request response. Using an API often requires a session of steps. For example, creating a user, signing in, creating an object, and then modifying that object. So this is a sequence of steps that an API session entails, and Postman is a format that is so popular in the development world and such a terrific tool that we use the Postman formats for a session for an API as our input formats. So every company that has an API probably has some developers that can use Postman to form their input session for an API session, sort of a session of a user using the API. And we take this format, right? The format is essentially a JSON file. We can export the Postman session into a JSON file, which gives us the list of steps that the API user, be it a good user or an attacker, might be using. So again, an API session in Postman might be something like create a user, log in, create an object, modify this object. By exporting the session, we get a JSON file that formalizes this series of steps. Now comes the most important part. We start with a JSON file that explains the series of steps taken in the session. We put it into our engine, and what we do is we create many variants of this session. So the original session is the green path. This is how you use the API, how a good user might use the API. For example, a user, again, might sign in, create an object, modify it. In each of these steps, the user will be executing API requests and reading the responses, right? This might be happening behind the scenes where the user is using an application to some sort of client application to run all of these steps. And in each of these steps, each request will have headers and parameters and content sent to the API. Again, we start from the green path where the session is a list of steps taken against the API. And what we do is we create variants of this session. So if a session has, for example, 10 requests and responses, we create variants, and in each variant, we modify one of the requests or more, one of the parameters or more, trying to simulate an attacker. So again, what we do is we take the original session, which is a green, valid, successful use of the API, And we create hundreds of variants, trying every single possible attack by modifying the request payloads. So if we have 10 requests, our first variant might change the first request, change one of the fields there from an email to another string, or to a number, or to an object, or to an array, or to a SQL command. Hopefully you're starting to get the idea. We take our knowledge of how to hack essentially an API, we think like an attacker, and we use automation and AI to create all possible variants and thus simulate every possible attack that we can come up with against an API. So we start with one Postman session, we create hundreds of sessions, and then we execute all of them. In the screen, we can see an example. This is an internal screen from the under the hood of our API attack simulator, generated on this example input session, about 130 sessions. And then we execute them one by one. Executing a session means running this sequence of steps. Same sequence as the green path, where we sign in, create an object, for example, modify it, and so on. The input is an arbitrary Postman session. So it's an arbitrary API session. Whatever series of steps taken against the API, the attack simulator does not need to know ahead of time what's going to happen. It can just receive an arbitrary list of steps and creates all possible variants of how to take this series of steps and modify them in order to uncover attacks and vulnerabilities on the API. Here we can see examples of the summary of the results of running each of these sessions. So in this example input API session, in this example input Postman collection, we created 127 variants, and we run each of them. We have mismatch attacks, we have authentication removal attacks, we have authorization fuzzing attacks. In each of the attack types, we modify different parts of the session. We really try to automate everything an attacker might do, anything a penetration tester might do. For each session, after we run all of the requests, we summarize the results, we analyze the results, again, using both cybersecurity algorithms and AI, machine learning, and we can figure out which of the responses signify a potential security problem in the API. Using this logic, we assign each session a score. If the score is high enough, this is a variance on the API session that warrants further investigation because it likely has uncovered some sort of problem with the API. So, for example, we might change a parameter from the expected type to a different type and see how the server responds. We might remove the authentication from a request that has authentication and see how the server responds. These are the same steps a penetration tester or an actual attacker might take. And by running this using automation, we can throw the power of 100 penetration tests at our server, at any arbitrary server, and uncover all the API issues that we can find there. Digging a little bit deeper, this is just to, again, explain a little bit deeper how each attack works. An example of a session, this is a BOLA attack, where we realize that if we change one of the parameters trying to execute a BOLA attack and we get a successful result, we uncover a BOLA vulnerability in the code through an automatic one of the sessions that was generated. So one of these sessions is a BOLA attack, and when we analyze the results of each attack, we can find that in this attack, in this session, what we can see here is each request response cycle and what we sent and what we received and what we changed and what we expected to happen. Then we can see that in one of the requests, in this example, the technical details are not too important. I'm just illustrating the type of flow that our logic has. You can see that in one of the requests where we changed the user ID to see if we could uncover access to an object that we don't actually have authorization to hit. And we see that we are able to successfully access objects outside the authorization of the user of that session, right? Or in short, we found a BOLA vulnerability in the API. Now, because we could do this through a simulator, we did not need to do this manually, and we can benefit from the powers of automation and AI and really just immediately find a whole slew of vulnerabilities in our code. Again, this is the actual vulnerability itself, where the user ID here was changed. We still got a 200 result. which signifies to us that the operation was successful at the HTTP level, but failed at the security and business logic level, because it should not have been successful, because we were attacking an API using a user ID that does not match the authorization sent in this request. So again, in this request, this is a BOLA attack, and what we did was we changed the user ID upon which the operation is executed without changing the user ID of the authorization. So what we see is that one user can affect other users' data. This is a BOLA problem. After we run our simulator and we create, so I'm going to go back and just go through this quickly again. We're looking to create a list of vulnerabilities in our API through an API attack simulation. We take a postman input as the seed for a correct usage flow of the API. In a JSON format, we generate hundreds of variants trying to change the session a little bit in this direction, a little bit in that direction, trying to figure out how to find a variant that will uncover a problem or a vulnerability in the API. We execute all of these, we generate all these variants, we run all of them, we analyze the results, and we find actual problems, and then we can summarize this view for the security team, telling them, here are a list of actual found problems in your API, right? This isn't more than monitoring and more than alerting when something suspicious happens. We can actually alert before anything happens. We can scan and find concrete vulnerabilities in the API. Digging a little deeper, we, of course, offer for each, what you want to do after executing a successful attack simulation is for each found vulnerability, you want to find, okay, this is the route, this is what we sent. So in this example, as an example, we're trying to sign up and sending a phone number instead of an email, right? And we expect a properly secured API to reject this, saying, hey, this isn't an email, I'm not even going to process this. And instead, we get a 200 response. So this is an example of how we want to uncover more than existing vulnerabilities. We also want to uncover any part of the code base where a security vulnerability is possible to happen because we can detect that not sufficient validation has been done, right? So we're aiming to uncover both exploitable existing vulnerabilities which already expose information or capabilities, and also highlight areas of the code where we think the development team might want to focus and make sure they apply the proper security. We offer an automatic generated code example of how the dev team should ameliorate and fix these vulnerabilities and problems with the validation of the data. The idea, of course, again, behind simulating an API attack is to find your own vulnerabilities in the field and bridge the security and dev teams together to know what they need to fix and how to fix it before the attackers find it and exploit it. It's important to mention that this effort is a very complex task, right? I can tell you just on a personal note, as the individual leading this effort, both the construction of an API simulator and, no less important than that, the formation and understanding of how to analyze results and figure out what kind of result signifies a vulnerability or a security problem versus what sort of results is an okay problem is a concrete problem. It's a very difficult technical task. We're going to open source parts of the system, and we will be looking for contributors from individuals and companies that want to help us make this something that is beneficial for the entire community, right? API security, much like other security types, is a team and community effort in figuring out how to stop the bad guys and how to work together to protect us all. So we are hiring all over the world people who are experts in API security and are interested in such difficult problems, and we will be open sourcing parts of the core parts of our engine, and we'll be looking to collaborate on all of this. You're very welcome to get in touch and speak with us about this. A little bit, 2 words about myself. My name's Sal Rafaeli. I'm an API security expert. This is my website, and I lead the attack simulator at WIB. And I think we have 5 minutes for questions.
Yes, thank you, Sala. That was fascinating. So I want to start with a question. So what do you use the coolest thing about an attack simulator like this from the developer perspective?
Right. Well, I think there are cool things in various aspects about this. I think as a developer, it's really important to have a powerful tool that you can use to uncover the vulnerabilities in your API automatically, because pen testing is a very time and effort consuming endeavor. It's very expensive at the human and labor level. So having a tool that can do it automatically for you, that can just run all pen testing knowledge against the API automatically, even as part of the CI/CD process, so both for development and for the security teams, to help them uncover their vulnerabilities. Even more interesting than developers, I think it's cool for security teams to have a tool that is essentially the strongest cybersecurity weapon, I guess, against APIs, is the way I view it. So if you think like an attacker, which is always very valuable, right? If you're going to try to defend your API, you want to think what the attackers are going to be doing. The attackers will absolutely, if they have the resources for it, will be employing such weaponry against your API, right? Employing a tool that can, my favorite phrase is just throw the kitchen sink, just use everything possible to scan the API. Really, one thing that stands out in the world of API security is that the API itself is exposed to the public. So an attacker can sit all day and night and use their automation tools to scan it, looking for vulnerabilities. And I think it's cool that organizations will have the ability to use the same sort of weapons themselves to make sure their APIs have uncovered all vulnerabilities before the attackers do.
Right, yeah. And that's interesting what you said. I like what you said about thinking like a hacker. So how do you do that as a team? How do you stay one step ahead, essentially? Or try to stay anyway? What's some of the thinking behind that?
Well, a lot of it is experience. So it's very hard to, experience in API security, hacking and defending is something that can't really be summed up succinctly, but it can be applied to tools that incorporate a lot of AI, especially to sort of try to emulate the steps an attacker might take. So an attacker might look at an API, run an attack, see the results, take a step to the left, change the payload that they send, see the results, log all this, and sort of try to craft a path, not unlike someone trying to maybe climb a wall, looking for things they can hold on to, right? By automating this process, we really speed up the speed and depth and breadth of attacks, really enabling someone to essentially attack an API with much more velocity and creativity and just scope than an individual might be able to do.
Okay, interesting. No, I like that. We have time for, I think, one more question. So just really quickly, based on what you see, are you seeing some sort of trends in the types of attacks that you're able to detect with this tool that you're building?
So this tool doesn't detect attacks, it detects the vulnerabilities. We're definitely seeing, I think the OWASP top 10 is the best place to follow the trends. That's who we follow, and this doesn't correlate a lot with what we see in the field, because these are actual vulnerabilities that developers and dev teams, really, companies, really, security can never be really assigned to a single individual. It's a team effort, it's a company effort to make sure all bases are covered and that all the vulnerabilities are patched. So we're seeing all kinds of API problems. In fact, we've been seeing them for a very long time now. We're happy that API security is rising in awareness industry, because the attackers have known about these vulnerabilities for as long as I can remember. Right? We've been hacking and seeing people hack APIs using these techniques for a very long time. So it's important to give to shift the balance of power using technology back to us, back to the good guys, to the defenders.
Yes, definitely. I think that's a perfect note to end on. Thank you very much, Sal. It was fascinating to see your presentation. Thank you.
My pleasure, Genka. Thank you, guys.